Hi everyone, my name is Thomas Kim. Today is August 9th, 2019. This is my 33rd episode about graph in C++. In our previous episode, we learned about C++ containers for elements of heterogeneous types. If you haven't watched my previous video, please double-click this link and watch this video. I posted this video on 1st of August and up to this point, 82 clicks I received for this video and nobody gave me like button. I'm a little bit disappointed. Anyway, in this episode, I will help you how to overload the stream output operator for STD variant and STD tuple. I actually filmed about how to overload output operator for STD tuple and STD variant in this video, but in this session I will further extend this output stream operator for interoperability between tuple and variant, tuple of variance, and variant of tuples. Without further ado, let's get started. Start Visual Studio Code. If you open CPP extension in Visual Studio Code, you can find the graph subfolder. Click graph subfolder and click this button, 33 tuple variant.cpp, hit enter. Ctrl V, include talk play fun, output HPP, namespace, types, talk play fun, types. I defined namespace alias, talk play fun, stream, auto, ender, talk play fun, ender. Void test tuple of variance, and I will also define a function test variant of tuples. Int main. We will first test tuple of variance, this function. I copied the function name and pasted it here. In this function, using name t std string, using age t int, using weight t double. Now I define two variants like this, using name age btt std variant, name t age t. Okay, we defined one variant type. This is one variant type. It can take name or age. Okay, I define another one using age, weight, btt, std, variant, age t, weight t. So we defined the two variants. Bt means variant. Okay. Now we are defining tuple. Tuple t, std, tuple, name, age, btt, age, weight, btt. So we define the tuple type. Then we define an element of tuple like this, tuple t, tpl. Okay, we will initialize it. The first type, this is the first type of tuple, and the second type is age variant t. So we are initializing two elements. The first element of this tuple is name age t. Name age can take either name, string type, or age type. So I will define name, Sophie, Turner. In case of age and weight, I will define 22.0, 7.0. Okay, we defined two types. Now we can display TPL, TPL, and now start command prompt. You should be in CPP extension graph subfolder. G++. We are using GNU compiler, SDD, C++ 1733, tuple variant.cpp, hit enter. CLS. Okay, so tuple TPL is an instance of tuple T. It can be either variant, type, name, age, BTT. Also, it can be age, weight, BTT. Okay. Now we can modify tuple like this. Auto. We will get the first element type. Say name, age, std, get name, age, btt, say tpl. Okay, we can modify like this. Name, age. Please note that name, age is type is it can be either name or age. So I will modify it into age. I modified the first element of this tuple. Now we display once again like this. In the command prompt once again, we build again. Voila. This tuple is now 30 and 3.14 blah blah blah. So it works successfully. The point here is how I defined this operator, stream output operator, how I defined this stream output operator such that this complex data structure can be properly displayed. Please note that this is tuple of variance. Okay, now I will copy this part and paste it here. We now define two tuples using name, age, tpl, t, std, tuple, name t, age t. I defined one tuple type using age, weight, tuple, t, std, tuple, age t, weight t. So I defined two tuple type like this using variant t, std, variant, name, age, tuple t, age, weight, tuple t. So we defined a variant. This is a variant of tuples. Okay, please note that this is type tuple and this is also type tuple. Here we define an instance variant tbt. We initialize it with age tuple t like this. It can be either name. We have to provide two elements, name and age. So Sophie and age will be 20. Okay, so we define a variant of tuple. Then we display stream bt, bt, and there. Now I copy this function name and paste it here. I will disable it. Then here we modify bt. Now using this, please note that age weight is tuple, so we have to provide two elements. One is age is integer. For example, weight is type double, so I would say 45.6. Okay, now I display once again. Now let's build CLS. Voila. At this point, SOP20 is displayed. At this point, 45.6 is displayed. The point here is how I defined this alpha stream operator such that this stream class can handle variant of tuple type successfully. In this case, this is tuple of variance. How this stream operator is defined such that it can handle tuple of variance, and in this case, variant of tuples. Now I close this file. Here again, select graph again, click this button, 33, variant, tuple, output, .cpp, hit enter, Ctrl V. We need to include IO stream, include type trace, include tuple, include variant. I will define a type function, template, type name, type, using remove, constant volatile, reference, t, std, remove, reference, t, type. From here, std, remove, cv, t, std, remove, reference, and constant volatile. From type. I will create another type function, template, type name, type, struct, is variant, st, static, context pair, bool, value, false. I copy this struct once again. Now I specialize it here. I will modify this part. Types, std, variant, types. In this case, it should be true. Then here, I define a type function like this. Template, type name, type, context pair, bool, is variant, v. We call this function like this, type, value, and from this type, we have to remove constant reference like this. Okay, don't forget this part. Now I create another type function, template, type name, type, struct is tuple st static context sphere bool value false. I copy once again, copy, pasted, modify like this, std, tuple, types. Now it should be true. Once again here, template, type name, type, context sphere, bool is tuple v. We copy this struct and provide type value. We have to remove constant reference. Copy this, paste, modify like this. Now we defined these two type functions and along this one. Now here we define template size t, start index size t, end index, struct static loop. Please note that this is struct. Here void, I say static void, static void print tuple std ostream os constant std tuple types tpl. Of course, template, type name, types. I defined one function. I copy once again. I copied and pasted it here. Now it becomes print variant, and it should be variant, and it should be VRT, variant. In the static loop structure, we defined two static functions. One is print tuple, another is print variant. And here, I will copy once again, copy, pasted. Now remove static and copy once again this part, paste, remove static. Now I copy the function name, copy, paste it here. This is declaration. And I copy once again, copy, paste it here. I made two forward declaration, template, type name, types, std, ostream, operator, std, ostream, os, constant, std, tuple, types, tpl, return, os. I copy once again, pasted. It now becomes variant, VRT. So from this function, calls this tuple function like this. We are defining tuple type first. If context sphere std tuple size, or we can just say size of types equal 0 OS. This is empty tuple. Else, otherwise, we call this function OS TPL. Well, we can just forward. We can just forward like this. In the same manner, I will copy and paste it here. Now it is variant. Okay, print variant. This function here, if context sphere size of types equal 0, else OS, this is empty tuple, return OS. No, we don't need to return. Otherwise, OS, we call this function in the static loop like this. 0, size of types, we call this member function. Please note that this is template function, so template, and it takes OS and tuple. OS, we close it. Now in this case, we can simply forward static loop 0, size of types, template, print variant, OS VRT. So we are calling this function, these member functions. So we defined print variant, print tuple, and it forwards to this function. Also here, I will create another function. If context sphere size of types 0, or we can say not 0. Then we call this function. Now here, if context sphere start index is this index, is not equal, start index is not equal to end index, we are printing tuple, so we can get elements like this. Although E is element of tuple, std get start index tpl, then OS E. Here, if context sphere start index plus 1 is not equal to end index. Now here we call this function recursively by forwarding OS and TPL, but this is a member of this static loop like this. Start index plus 1 size of types. Since this print tuple itself is template function. We need a keyword template. We are calling this print tuple recursively, like this. This is recursion. Before we call this function recursively, we print out delimiter. OS, this is delimiter. Now we defined print tuple. Let's define print variant. From this function called print variant here, if context pair start index is not equal to end index, please note that this start index is coming from here, or e std get if start index, we have to pass address vrt. It returns pointer ptr like this. If ptr is valid, then we have to print out os ptr, then return. Okay, this return statement is important. If context pair start index plus 1 is not equal to end index, or we can just say less than. Okay, or we can just say less than. Then we call this function recursively. OS variant. Once again, this belongs to this struct start index plus 1 size of types. This function is also template function, so we need keyword template here. We defined variant, print variant function, also print tuple, and these functions are forwarded through these two functions, one function and this function. Here in this function variant, I made mistake. It should be variant. Okay, now void test simple tuple and variant int main. I call this function using name t std string, using age t int, using weight t double, using tuple t std tuple, name t, age t, weight t. I defined one tuple type using variant t std variant name t, age t, weight t. So I defined tuple type and variant type. Tuple t. In case of tuple, we have to provide 3 arguments. Name is Sophie, Turner, age is 20, weight is 56.5 kilograms. Variant t b, it can be either name or age or weight. I will just say Thomas Kim. I defined variant. Now we print out std cout t equal t and l std and l. I copy once again, copy, pasted. It should be variant b V. Now in command prompt once again, 33 variant tuple CPP, hit enter. 33 variant tuple output, hit enter. Wow, I think I made some mistake here. It should be greater than 0. In case of variant, in case of variant, this is variant, the parameter count should be 1 or greater than 1. So I have to modify like this, type, and copy it to here. Then I have to fix it once again in this function. It should be type name type, and copy it here. Then it should be, it cannot be 0 in this case. Now instead I will fix like this. If VRT index equals std variant n4, like this. I fixed like this, and it should be +1. Okay, I fixed this part. Also we have to modify this part. Copy this. Don't forget that we also have to modify here like this, and we delete it. Please don't forget this part. Now let's try once again. Hit enter. 115, type name, and also it should be, it's correct. Now let's build once again. Okay, it built. Now it works successfully for tuple and for variant. Please note that in case of variant, this test is important because when the VART is not initialized, if VART is not initialized, we cannot access the element. Also, I will modify this part. In this case, we don't need this size t. I will modify this part like this. This is tuple type. I modified and modified. Also, this is not template now. And we don't need this size t. Instead, we can just say end index. Okay, I fixed this part and also this part. Also here, we don't need this. I say variant type. I will modify like this, end index. Sorry, this is still template, so I will put it template here back. So I modified this part and this part. Also this part and this part. Now let's build once again. Okay, it builds successfully. Now I copy this function, copy, pasted it here. I say advanced, tuple and variant. Copy this function name and paste it here. I disable it. Now here I change TPL, T, and VRT, T. I delete this part So this is tuple, this is variant. Now we define using tuple t std tuple name t tuple t vrt t. Tuple t is a tuple with name t, another tuple tpl t, a variant vrt t as its element types. Okay, also using variant t std variant name t. Variant has a member tuple t vrt t. So variant t is a variant with name t, a tuple tpl t, another variant vrt t as its element types. Now here tuple t, we need 3 element name. Name is simply string, advanced, tuple. Second element is tuple t. This second element can have name, age, weight. So here Sophie, Turner. The second element age is int 20. Last element is double 56.7. And the third element is variant. This variant can be name, age, or weight. I say Stephen Lee. Okay, this is very complex tuple type. Variant TB. This variant can take name, tuple, or another variant. We will start with tuple. This tuple can take name, advanced, variant. It can have age 1, weight 22.0, 7.0. Okay, so we initialize T and B. Now std cout T equal T std and there paste it here B. Okay, now in the command prompt rebuild. Wow, it worked. How it worked? Correctly understanding how this function works, especially in this part and in this part of code, is very important. For example, this tuple t is an instance of tuple t. It is a tuple that has element tuple t, tpl t, and variant t. Again, in case of variant b, variant t is a variant with tuple and variant as its element type. Okay, so initially it calls this operator stream output operator, and this function gets called when the type is tuple. When the type is variant, this operator stream output operator is called. It then calls this function print tuple function again. This print tuple function. Then this print tuple function calls this member function. Okay? When the element of this tuple element itself is a tuple, then this operator is recursively called. This operator is called. Okay? So this operator is called again. Then it calls tuple, this function. Then it calls this function again. So when element E of tuple TPL is a tuple, then this function is recursively called. When element of tuple TPL is a variant, if E is a type of variant, then this function, this calls this operator. Because element is variant, then it calls this variant function, then it calls this variant function. So here, if the element of tuple TPL is a variant, this function call actually calls this print variant function. Again here, if the variant type VRT element is current element is, for example, this is variant, then this function is recursively called. If this type is tuple, then this function gets called recursively. That's why this function and this code works correctly. Understanding this point is very important. So I will summarize it here. When you overload operators for C++ class, you should be extremely careful for recursive function call. Most of the time, it is valid operation, but in some rare case, it can cause trouble to your application development. I will talk more about this part in some rare cases. If you overload operator for C++ class object, operator overloading can be called recursively. It can cause trouble to your application. I will talk more about this in some future episode. So most of the time, this code is perfect. However, for more advanced case, this approach can cause trouble. Also, you should keep in mind that operator overloading at global scope is very dangerous practice. You should almost always prevent operator overloading at global scope. So we introduce namespace tutorial. I introduced namespace tutorial up to this point. End of namespace tutorial. I will indent a little bit. So I indented. If we compile it once again, it does not work. Okay? So what we have to change is this part. This operator now belongs to tutorial namespace. In this namespace, we defined operator overloading. Okay? So don't do this. Do not do this using namespace tutorial. Don't do this. Instead, make a block, make a scope, local scope, then using namespace tutorial. Okay? Please confine your namespace using declaration to a scope. Always confine using declaration of the namespace with local block like this. If we build once again, we also have to fix here namespace tutorial. Say using namespace tutorial. Using namespace tutorial. Now let's build once again. Okay, it works successfully. So when you use using namespace statement, always confine using declaration. I emphasize once again here, when you use operator overloading, you have to be extremely careful of recursive function call. This code is recursive function call. This code is identical like this. Using element T, DECL type E, if context pair is tuple B, ELT, then we are calling this function indirectly through this function. Okay, this is recursion, TPL. Else if context pair is variant B, ELT, then we are calling this function indirectly like this. Copy this, paste, OS, E. Sorry, it is E. Okay? Else, OS, E. So this part of code, this single line of code is exactly identical to this. Also, in this part of code is recursive function call using ELT, DECL type, PTR, if context pair is variant B, ELT, we are actually calling this function like this. OS, PTR, recursion. Else if context pair is tuple ELT, print tuple OS, PTR, recursion. Else OS, PTR. This is not recursion. Okay? When you use operator overloading, be extremely careful for recursive function call. At the command prompt, we build again CLS. Now everything works as expected. Please understand that you should be extremely careful when you use operator overloading. I will fix this part a little bit. I think it is using this function, I guess. So instead of doing this, I will call like this. Copy like this. I will give scope. And also here, I will give scope. Now let's build once again. Now everything works perfectly. I will upload complete source code to my website, extension talkplayfun.com. By the time you watch this video, if you click this link and unzip the file, under CPP extension grep folder, you can find the complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.